In this video, we're going to simplify radicals that have variables in it. So we're going to go over this first example here. In our previous videos, we've gone over how to simplify a radical that just has numbers. The rules are the same for if it has variables. So we're going to start by simplifying the number first. Look at the index right here. There's no index. That means there's an index of 2. We're looking for pairs. If I have a pair of a number, I can set it on the outside. Any singles I have left over go on the inside. So 12, make an upside down division bar. 12 divided by 2 is 6. Keep using 2 until I can't use it anymore, and keep going until I get a prime number. So I have a pair of 2's. That means I make my radical symbol. I'm going to write a 2, and I'm going to leave some space in between the radical symbol and the 2 because I need to put some variables out here, specifically some x's out here. How did I know to put a 2 out here? Because I had a pair of 2's. Anything I have a single of stays up under there. I'm going to do the same thing with this variable right here. This is x to the 4th power. That means I'm going to have 1, 2, 3, 4 x's being multiplied together. And when I start pairing those up, I've got 1, 2 pairs. That means there are 2 x's on the outside. And how do I write 2 x's being multiplied together? I use an exponent, x to the 2nd power. So just like numbers, I pair the variables up. A pair allows me to write 1 on the outside. If I have any singles left over, that goes on the inside. Our next example. I need to simplify the square root of 8 first. So I take 8, start dividing it by 2, keep going until I get a prime number. There's my prime number. Make my radical symbol. A pair of 2's right here allows me to write 1, 2 on the outside. And because I'm dealing with variables, I need to leave some space here. That pair of 2's allows me to write a 2 on the outside. I've got a single 2. It goes on the inside. Notice I already have a 2 out here. So this 2 right here came from that pair. I need to make sure that I write this 2 that's already out there as well. And remember, those are going to get multiplied together. Now I need to deal with these variables right here. Got all the numbers in the right spot. Let's deal with these x's. 1, 2, 3, 4, 5. I'm going to pair them up. There's a pair, and there's a pair. So how many x's go on the outside? 2 of them, and how do I denote that? X squared, because they're going to be being multiplied together. Notice I had a single 2. It went up under the radical symbol. I have a single x left over. That means it's going to be left over up under the radical symbol. I multiply these on the outside together. This is what this problem looks like once it's simplified. Our next example. I already have a 5 on the outside, so I need to make sure that 5 gets put out here. Make some room for any x's that are going to go out here. Write my radical symbol, and let's start with simplifying 150. Take 150, divide it by 2. 75. I can't divide 75 by 2, but I can divide it by 3 and get 25. I can divide 25 by 5, and I stop when I get a prime number. Again, I'm looking for pairs. There is a pair right there, so that means I can write another 5 out here on the outside. Here's where this 5 came from, and here's where this 5 came from. Now I need to look and see what numbers go on the inside. I've got a 2 and a 3. I put 2 times 3, because just like any numbers that go on the outside, they get multiplied together. Any singles left over go on the inside and get multiplied together. Now I need to see what variables go on the outside. I only have one x. For me to be able to write an x on the outside, I would have to have a pair of x's. I don't have a pair of x's. I've only got a single x. So the single x stays up under that radical symbol. I can't put any x's on the outside. I multiply my numbers on the outside together. I get 25. I multiply everything up under the radical symbol together. I get 6x. Now there is another method for figuring out how many x's, y's, how many variables go on the outside. I'm going to show you this other method. So again, I'm going to take 50 and start simplifying the square root of 50. Divide it by 2, I get 25. Divide that by 5, I get 5. I make my radical symbol. There's my 2. I need to make sure I have it on the outside before I put a 5 with it also on the outside. Those numbers on the outside get multiplied together. Now, here's another method I can use instead of writing all the x's out or writing all the y's out. Since I've got an index of 2, what I'm going to do is I'm going to take this 3 for my x's and I'm going to divide it by 2 because that's pairing them up. 3 divided by 2, or how many times will 2 go into 3? It'll go into it 1 time. 1 times 2 is 2 with 1 left over. This is how many goes on the outside, and this is how many go on the inside. So I need to have 1x on the outside, and I need to have 1x left over on the inside. What else goes on the inside with that x? A 2 right there. Anything I have a single of. So let's try it with the y's. I'm going to take 4 and I'm going to divide it by 2. Why am I dividing it by 2? Because I've got an index of 2 here. 4 divided by 2, or how many times will 2 go into 4? 2 times. 2 times 2 is 4 with 0 left over. This top number is how many goes on the outside. The bottom number is how many go on the inside. There are no y's left over on the inside. And how many y's go on the outside? 2 of them, like that. So let's multiply everything on the outside here and multiply what's left over on the inside. Dividing by the index is another way. If you need to write those x's out and go x, x, x and pair them up like that and go, hey, 1x goes on the outside because I have a pair of them with 1 left over. If you need to write the y's out like this and pair those up, that's fine as well. This dividing method is just another way of figuring out how many go on the outside.